Phil, you're better at it than me.
Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. Welcome to the show. It is Free Energy Friday. It is Friday, January 9th, 2026. Welcome to the show. We got a full cast on tonight. Bernie will be hopping on here in just a couple of minutes. He's just firing up his computer. As always, we have Mr. Nathan joining us tonight, and we have Joel, and we have Lulu. She's hiding there in the corner, and we got Philip, and last but not least, we have our special guest tonight, Dr. Yu. Welcome to the show.
Thanks. I just want to say that I agree with what you're going to say ahead, Dr. Yu.
Oh, sure.
Yeah, I agree 100%.
Oh my goodness.
I understand I understand everything you're going to say.
Thank you for your support. Okay.
Yeah, we're definitely going to get into real more depth on Dr. Yu's theories of electromagnetism, and well, we got a full crew tonight, so we're going to ask Dr. Yu questions throughout the evening, and also live chat is open. If you have any questions, comments, they're going to be posted live and on the screen there, so you can see all the questions come up, and hopefully we'll get to all of that. So, yeah, I just want to say, my last week's been really, really good. I've been doing a lot of prototyping of my solid-state electrolyte for my power cell technology, and I got the last component that I need to make the solid-state electrolyte. And this is where the industry is going now. This is kind of like the holy grail of battery technology, is solid state. So I watched a couple of lectures from some pretty prominent universities around the world, and it seems that what they're working on, I'm actually a little bit ahead of them in some aspects of my research. As far as when it comes to longevity of a cell, everybody's still hooked on lithium, and that's where the issue is with lithium. I decided to go another route. I'm using magnesium for several reasons. They will last longer. They don't have thermal runaway. Also, I've tested my cells in minus 12 degrees Celsius temperatures. They hold stable voltages and currents at sub-zero temperatures, which is very important. And as well, we're in the middle of winter, but when the summer comes up, it gets pretty hot here in Toronto. So on the hot days, I'll be testing these cells in heat as well. So I'll be able to get some good data on that. And, it's a constant learning process making these solid-state electrolytes. They're not easy to make. I've done so much reading on the stuff. Like, I'm reading like university papers, and there's only two places right now that are working on magnesium power cells like I am. The one country is, there's two universities in Japan that are working on it, and there's one university out here in Canada in Vancouver that are testing magnesium cells. Everybody else is still hooked on either sodium, or they're still stuck on the lithium cells. So I decided to go the different route, working with magnesium, because magnesium is so abundant. It's not a very expensive metal. It's also a metal that can be recycled. So there's a great aspect of recycling. Most of the components in my power cells are non-toxic. Actually, one component I could actually consume. which is really kind of mind-boggling when you think about it. Okay, we have Bernie here, but I'll talk more about I'll talk about more of the power cells either later on the show or next week. But tonight we got Bernie. I'll let him take the reins here, and we'll get the show on the road.
All right. Sorry for the delay there. Computer takes a while to load up, but we are joined with amazing Dr. Weiping Yu, joining us as a civilian, despite his awesome job at NASA. And we have Joe and Nathan joining us to go over the different experiments that we are going to be conducting very shortly, starting next week once I'm down in California with Nathan. And so we'll cover that first, and then after that we'll get to Phil's updates with his anti-gravity magnetic work and mathematic theories, and get Weiping's expertise opinions on everything. So to start out, the first experiments that myself and Nathan will be reproducing is a type of electrolysis plasma arc fusion, and it's one that myself and Jeremiah had replicated about a couple of years ago now, but it's a very simple and easy form of actual plasma fusion. Well, nuclear, I guess technically it's nuclear electrochemistry, but where the hydrogen and the specific atomic hydrogen produced in the electrolysis reaction through the plasma arc that forms between the electrodes of the anode and cathode, that plasma is enough that it's this equivalent to the surface of the sun, or where you need the fusion of, or capable of having the fusion of hydrogen into helium around the actual, I guess, ionized plasma through the water. And I'm sorry, I'm just trying to pull up the pictures of the last one we did, if I can find it quickly. And nope. Okay, so the basis of it is when the original, as the reaction starts out, the color spectrum of the arc light is an orange to a yellow, and that in that reaction, it's just simple hydrogen that is being produced out of the electrolysis, but it's a lot of hydrogen compared to as my regular reactions, where I'm only using 5 volts of electricity for a minimum amount of hydrogen. When we step it up into the thousands of volts, all of a sudden you get a ridiculous amount coming off of the plasma arc. But as soon as you reach a higher potential of the full white light spectrum, that's when the actual fusion of the hydrogen into the helium starts occurring, and that it has to do with that full spectrum light. And that's kind of, it also ties into aspects of what Joe, Nathan, and shout out Sean Calderon, who's not here, with your guys's RAV fusion model works with. So now that I've done that in a bit of a word salad, Weiping, do you mind giving your opinion on, because we were talking prior to this, why you, or how you understand the process of the hydrogen turning into helium in that reaction?
I could let Joe take care of that one. Joe's real good at the hydrogen and helium.
Yeah, well, to add on to what Bernie was saying, because I know you wanted Dr. Yu's opinion on that. What the work that Nathan and I are doing, and how that runs parallel to what Bernie was just saying, is that we kind of realized a few different reactions that occur between an anode and a cathode, and actually what defines an anode and a cathode in a relationship when they're not meeting at a circuit. And by introducing, an arc from the anode into a diffuse state cathode through an intermedium, think of it as a membrane, right? An insulative membrane. By allowing that to occur, what happens is that there's an asymmetric energy exchange that occurs between the anode and the cathode. That allows for channeling to occur from the anode side, creating material deposition in the intermedium. Once that the material deposition is in place, there becomes a free flow of energy exchange between the anode and the cathode side that are actually coming at each other and repelling from each other, coming back and then crossing. And it's on that cross that we become having transmutation events. And it also creates what we believe to be energy well of high potential due to external magnetic force eddy currents. It's forming this like a vortex cluster. Okay, that's actually feeding plasma ball that's on the anode bias side. And on the cathode bias side, we have what appears to be the accumulation and fractal structuring dendritically of low energy state atomic mass. So effectively, we're stripping the electrons from the atomic mass, accumulating the atomic mass on the cathodic side and structuring it, making an energy well of high energy potential on the anodic side, and then reintroducing it in a balanced, asymmetric, non-equilibrium state in a rotational, self-organized plasma. And we do this under atmospheric conditions with no external magnetism. So that's what we're doing.
Although I see Weiping there, because it's like what the definition of what an actual electron is per se isn't the current model and how it works. So
yeah, and I saw a doctor use a description of that. Him and I have extraordinarily similar thoughts on that. There's something else I want to discuss later on, but I won't open that can of worms right now. But it has to do with time and gravity as an energy exchange, but we'll get there.
So Bernie, I put up a picture so we can get a good look at what we're talking about here. So as you can see, the anode cathode relationship there, it's spinning the ball of plasma in the center. What we noticed was when you slow this thing down and put it in slow motion, you can see the inside's white, the outside is yellow. You can see the full color spectrum coming off on it to the left. You can also see that it's building out a satellite. That's not a camera effect in the way that the lens actually looks at this thing. It's more of an effect of a magnifying glass from the RAB itself or the plasma you see to the object that's out there. And what you can actually see is what looks like the magnetic field going out there. In the video of this, the purple part or the pink part, when you see right there with the green inside of it, will actually swirl. And it swirls right along that line on the outside there. And you can see the counter to that on the upper right, you'll see another ball up there. And what it's showing you is the opposite side of it to make balance. So as it builds out the satellite, it also builds out another item back there. We can't never normally detect it with our eyes. We're lucky to capture it here, but the magnetic field and everything else follows it. So it knows it's there. The field forces are there around it. That's what's very interesting about what we're doing here. It's not just a simple reaction. And how we get there is we set the cathode in the experiment. So we'll put a smaller cathode in there, and then we'll hit it once with a very low voltage, just a regular boom hit shot of what we want to get into the RAV itself. What that does is it presets the condition in the cathode. So now it'll make what looks like is a open pore source item on top of it, right? Like a little ball. But what that actually does is it sets the frequency inside of it to be set with the anode now. And in that, you get a stable reaction. So you no longer need the in-between material. I don't need clay. I don't need anything else. I could do it straight off of the cathode because it now has memory of it, of the exact frequency that I want to create, which now gives us the continuous effect that you see here in the way that everything builds out.
Yeah, and important just to note is that the what appears to be that lens effect that Nathan was talking about is actually representative of the high energy state, the vortex that's created. We've had numerous repeatable instances of the plasma ball consuming it and reacting to the consumption of that energy. There's a direct energy relationship between the plasma ball and the external energy well, and it appears that there's a fourth dimensional feed, like a quantum feed, quantum tunneling type thing that allows for this connection. And the way that it's picked up through the lens of the camera as a lens flare is only manifest based on its existence. It only exists under certain conditions, and it's reactive with the plasma sphere itself.
Right, and so that it makes sense in the fact that ionized gas, aka plasma, puts out light. So it's that this is the light wave particle duality coming in between a particle and the wave of plasma interacting with the matter and the energy. If that makes sense. Weiping, what are your thoughts on all of this, my friends?
Okay. I first of all, I wanted to understand where is the anode and where is the cathode. So the one with the alligator clip, is that an anode or it's a cathode?
So right on the alligator clip on the top, that's the anode.
Oh,
It'll come down to where the light starts.
is that the inside the white light ball? Is that right? Where is the where is the cathode then?
The cathode, you can't barely see it in here. It's center of the RAV on the bottom right.
Oh,
Yeah, so the plasma sphere is literally balanced on the tip. What Nathan was explaining was that to initiate this reaction in this particular configuration, there's in a low voltage, a timed low voltage arcing event that occurs that creates the destructuring of the cathode. So there's a phase change. During that phase change, the relationship between them is established and solidified in the ball, the molten ball that forms. Once that molten ball forms under those particular conditions, allows then when the system is reinitiated and powered up for the plasma ball to form, because those conditions have been set and they're custom set based on the relationship of the anode and the cathode.
Okay, I think, I think I can understand here. So, what kind of gas inside of the glass ball?
There's no glass ball, to be clear.
Oh, this is purely in the air.
Yes.
This is atmospheric conditions, no magnetism, which is why it's
sorry, just to interject. So Nathan brought up a picture of the RAV version, and so this is a secondary experiment compared to the first one I was describing in the electrolysis reaction. This is the RAV reactor, not the plasma arc electrolysis.
I think I understand. Thank you for explanation. I hope I give you some kind of rationale based on the yuan theory. So what happens to the anode and the cathode? So they are, when you have an electrical voltage, right, differential, they are from different magnetic pole. So let's say cathode is negative, basically it's a magnetic north, a south, and the cathode is magnetic south, and the anode that becomes a magnetic north. So so there are different polarity. So that's why when you form the arc, right? The arc basically it's a different polarity. So that's why form an electric field. So they align the arc in between cathode and anode. So that's where magnetic field align them. So that's why I keep something arc in between. Okay. So is the wind is north, wind is magnetic south. Okay. So now say where comes, so how could this arc, little arc, your low voltage arc, can interact with hydrogen in the air? Hydrogen stable structure is a H2 hydrogen. So basically, hydrogen, whenever you have H2, means you have two magnets. H2. So basically, the H, each H is a magnetic particle. Okay. So now you have a two. What that does is it forms a. I hope you can see this one. I'm not sure if you can. Are you able to zoom it out or something?
I can see, but
Okay,
yeah, please zoom in. Yep.
Yes. So everybody can see. First of all, in Yuan theory, the smallest particle or every small particle or composite particle made by magnets, it is a bigger magnet. It's a composite structure of magnets. So basically, we say hydrogen just one magnetic particle have both north and south. So what happens if you have two hydrogen atoms? It forms a molecule, and this molecule actually is appeared as a fairly stable structure, right? So that's actually a magnetic neutral. However, because it's just two molecules, you cannot three-dimensional totally neutralize, right? So you close enough, you still have a polarity. Okay, so that's what hydrogen molecule stable structure is. This kind of neutralize the particle. Okay. However, what happens under arc? You know what the arc? Arc is high frequency vibration. So just like light, light is we call the electromagnetic wave, right? So wave means it's vibration, right? So electricity is it's an orders magnitude stronger than light, because the light particle is like infinitesimal size of the unit, infinitesimal unit, form this kind of ocean, cosmic ocean. Okay, so that's vibrating. That's what the light is. Electricity, that's what is it? That's ionized particle, or you say every particle inside of the coil. That's atom. Every atom is a magnetic particle. So that means the magnetic particle is way bigger than the Yuan particle in the media, right? So that's why when you arc oscillating, so that means it ionizes the gas, ionizes the air molecules in your open air, right? So basically the atmosphere molecules, you ionize it. What happens if you ionize them? Let me show you. Original say neutral hydrogen. When you ionize, means you apply the strong magnetic force. One is south, one is north. You know what happens? Dislodge them. So then form a line between the arcs. The line between arcs is highly magnetic particle and in high vibration. When vibration of magnetic particle create the electricity and also create the light. So that's when we see light is electricity goes through the filament, right? What they do, because they create oscillation of particles. So that particle oscillation, that's a light. So that's when you see arc. So that means is a polarized air molecules. So instead of originally like hydrogen, like H2 is stable. Now you polarized becomes highly charged, and when they vibrating, you see you see lights. That's the white lights you see. Okay, so what happens now? So originally a stable hydrogen, you dislodge them. And of course, at a certain point, the high energy part, you not just dislodge them. This one, you could be individual. Hydrogen atoms could be becomes individual instead of H2. Right now, you become individual. That's where helium forms. When you're high enough, dislodge them, become charged, and make them separate. What happens? You have a highly charged, so that means hydrogen atom is a magnetic north and south becomes a charged particle. So what happens away from the arc? When this particle highly vibrating, right? So create this called impact. So that's why I create the lights. You hear sound. Sound is basically these charged particles impact each other. So that's why you hear sound, and you also see light. However, when these molecules becomes atoms, becomes charged, and away from the center, so that means when they cooling down. So that's the mistake by a fusion theory. Nuclear fusion theory is totally wrong. Nuclear fusion, think about it, we fuse two things together. That's exactly wrong. What happens, we separate them, and when these separated charged particle away from them, cooling down, what happens? They started combine with other particles. So it could be still form hydrogen, or could be, I have another set. I have another set. Okay. You know what happens? It's likely you could have 4 of them. Bernie, do you know what happens if you have 4 protons? What do you get? Helium.
Helium, yeah, yes.
That's where helium comes from. Okay.
I see what you're saying right there. That makes perfect sense. Okay, gotcha.
Oh my goodness! I know you have a high IQ.
Dr. Yu, just to kind of add into what you're saying, so it plays well, right? When this plasma ball separates the differentials, it does exactly what you're saying, by the way. What it ends up doing is it structures almost like centrifugally in the plasma sphere between the high and low energy states. And then there ends up being torsion boundaries, that end up keeping them separate. But then they reach certain points of intermedium, where they actually cross the laminosity of the torsion boundary, and then there's a combination of that. And it's under those conditions and compression through cavitation that the fusion is able to occur. And that, at least that's what we believe.
Right. So the word fusion is exactly the wrong idea. I know exactly what you mean. You try to explain the current phenomena. I would say the so-called nuclear fusion, we explained as fusing 2 things together. Let me tell you what I did. I'm my major actually is nuclear engineering and engineering physics. Okay, so I know this. So-called fusion, that's based on Albert Einstein said, we fuse 2 things together. What happens? You fuse 2 things together. After you fuse them together, you measure the mass is less than individual plus 1 plus 1. When you fuse them, so that's current explanation. That's the wrong explanation. Say, hey, you're fusing 2 things together, you're losing mass, and where does mass go? This is mass converted to energy. So that's why you get energy, fusion energy. Let me tell you, this is a completely wrong idea. So no wonder we have a fusion. It's almost 70 years now, right? from the 50s, or 60s fusion, and we talked about it so many years, and would never get materialized because they always try to increase the temperature to fuse them together. Let me tell you, whenever you increase the temperature, that means increase the vibration. You never fuse two things together. You will not. So what really happens is when you high energy separate them, when them cooling down, and then they formed, the particles slow down. So that means that magnetic force can interact too fast, so they bumping each other, right? But falling down, now they can form either back to hydrogen molecules, or they can form with four protons. So that's what helium nucleus was decay, right? That's where nuclear reaction it is. So basically, based on I believe the Joule and also Bernie is liquid, and Joule use open air, so use gas. You get exactly the same principle. Use electricity arc. Create a huge vibration, means separate, dislodge neutral particle to a individual part of helium atom, and then after you dislodge them, so they are starting very reactive, right? After they cooling down, and then gradually they attract each other, so now they form helium nucleus. So basically, if you use electricity as exciting force, even very, very low voltage, you mentioned about the low current, the low voltage, right?
Right, and so it's 5 volts is the minimum, right, of that reaction for there to start being that breakdown and reassembly.
Oh, 5 volts. You even know the critical threshold. Yeah, so then enough energy to break the air hydrogen atoms are down, and then when they cooling down, try to combine together, you will see neutrons. So that's what they say. Hey, I even detect a neutron. Neutron basically is what? Is neutral particles, right? Is the electron. So if you look at this one, if I can somehow combine this way to, I have 4 of them. I have 4 of them formed this way. You will have a 3-dimensional neutral particle. So that's where you see neutron, neutral particle, right? And also you see helium nucleus. The same thing. I hope I make myself clear. Bernie, does that make sense?
Absolutely. That makes a lot of sense to me. And I finally found, I had to go onto a phone and connect. I don't know. I had it on the computer before, but the pictures of the plasma arc electrolysis reaction that I was originally describing here. But yeah, so 100% with the 4, and that, so in my electrolysis, that at the 5 volts threshold, that it creates single atom atomic hydrogen, right? And that those bubbles, those nano bubbles, they sparkle. There's a little tiny sparkle of light when they form, and that's how you know that it's H1, not H2 hydrogens together. And that then you have them in their single states. It's much easier for them to be vibrating into and settle and fuse, like you said, into that 4 cluster, because they're not already attached doubly in the H2.
I hope I'm making sense.
Oh, to me, absolutely.
What about the lady? I know the lady last time asked great questions. Does that make sense to you, Yanni?
It does, and it's like new information. I'm trying to visualize it in my mind on, it's amazing. Like, I did not know the cooling process is what causes the
fusion.
The fusion, yes. So yeah,
that's complete. So I try to champion such simple idea.
Okay, sorry. Finally got.
Well, sometimes, Dr. Yu, it's just simply the way people
sorry.
describe it, because realistically, a cooling event is no different than saying a decompression event.
Yes, that's right. Yeah.
Is it not? And then they would totally accept that verbiage,
Oh, okay.
right? It's just all the way you say it, I think, but it's really the same.
Yes. I hope I contribute a little bit because this
Oh,
idea.
absolutely.
I try to convince
Absolutely,
my
yes.
professor. They don't listen, because they don't want to start a new paradigm.
Exactly, and I love how you explained the heating up, and we've been saying for a long time just how wrong the current model of hot plasma fusion is, and it's impossible. And like you stated, by putting the higher vibration energy in, it's literally making it more. Did Weiping just get the call from the government that we're releasing too much information? I don't know, but the fact is he'll be back, hopefully. But that it's Weiping just gave the actual explanation of why the tokamaks and why CERN and why, as you put more higher energy, the threshold of trying to create the full sun, the full heat, the full pressure of matter to fuse together, it makes it more impossible because you're strengthening those boundaries instead of weakening them. And it's the exact opposite, and it's why the tokamaks will never work, and that you have to get down to the smallest level of wavelength of energy where these bonds actually are, then the charges actually are, that you need to decrease and work from the smallest creation charge opposed to increasing the charge to the most maximum ever, which it's just like from the get-go you have to use all the energy possible to generate the amount of energy to create this mini sun tokamak plasma
Bernie, you're dead
reactor.
on, man, because tokamaks, they force containment,
exactly, right?
and
So it's
force containment is not the answer. Structured self-organization is self-containing. So,
Well said.
force containment is never going to be the answer. Not ideally.
Right, it's working against itself, and you're just wasting more and more energy and making it harder and harder to achieve what you're actually trying to do by doing that. So quickly, while I have this picture up, so this is the original picture experiment, the electrolysis that I was talking about, arc reactor, and this is where you have it is yellow, orange, and red, and this is where it's making the hydrogen. And then from that, as you increase the voltage and the temperature gets right and it gets to the right situation, then you get it into the pure white plasma arc, and it accelerates, or it moves up higher, and that's where you now have the hydrogen forming into the helium between the cathode and anode in there. So yeah, just
one last thing, Bernie. I had proposed an experiment to Nathan for when you guys get together, and I want to put it out there so it's in the ether. All right. What I was saying is that you should take one of your experiments, okay, that have atomics in it already, okay, and run a lead wire from one jar into a clean jar of water, okay, and use that as the cathode in a RAV reaction, okay. And what I want to see is if you could get low energy density atomic accumulation.
You're kind of giving away some of my secrets on other aspects of more advanced parts, but you're bang on with what you are putting forward.
So I already know the answer is probably going to be yeah, but I feel like that's something the world needs to see.
Anions and isotopes start forming in the secondary.
See, now the whole thing about it is, for the simple mind, how does the material make it from one jar to the other, and how does it structure up? Well, once you realize what matter actually is, you realize it's just moving the energy that it already is anyway, along with the energy as a carrier wave. That's all it's doing.
Right.
So just an opinion, but what do I know?
Well, so so people are like secrets are bad and gatekeeping. It's that this is literal national security level stuff that, you know, it's in my dead man switch, and you don't want to fully explain how easy it is to be making types of hydrogen isotopes and anions and so forth. And I'm just going to leave it at that for now.
I'll leave what I say in theory undefined, and then you could fuck around and find out. You know what it is or isn't. I'm just saying. I'll tell you all the secrets though. Just figure out what it means.
And that it's a very dangerous reaction as well, because that's when you're going to start getting radioactive isotopes that do have half-lives and decay as part of the output reaction. Well, I found that out the hard way 12 years ago and got very sick, and then I realized what was going on, and then it's like, you know, that's why I just don't talk about it too much, but well, there it is.
I disclaim that I'm only a thought person, and I actually do none of these experiments. I just pass my bad ideas along to everybody else.
Great ideas. So it's that they're great ideas, and it's that we got to get the science out there and make sure that people with bad ideas don't do bad things with this knowledge, and that it's able to be developed and utilized properly. And that another aspect of the reaction there I was showing of the hydrogen to helium was that it seems we have to set up, when we will with Nathan when we rerun this, to measure the energy in and the temperature, and that it seems like there was also a minimum double heat energy out compared to electric energy input in, so that you're also gaining essential over unity, but it's not over unity. It's coming from the unity of the equalization of those single hydrogen atoms into the 4-state neutral of the helium, and thus that's where the extra energy is coming from in how the reaction happens. So it's an exothermic electronuclear chemical reaction.
It's just about accounting the energy. It doesn't matter what kind it is. You just got to account for it. Hey, I wanted to put up that picture, Bernie. I wanted to show what happens when you put something in between the RAV and the cathode. And in this case, we put a material in there, and what we're actually growing, and it looks like snowflakes in there, is geometric structure.
Right. And so so you guys, this is from Sean Calderon, shout out to him, off of one of the RAVs, and that it's essentially a type of monoatomic quasi-crystal that's being formed out of the plasma and the charge. And it's is it a straight hydrogen? Is it a oxide, or is it of the actual element of the whether it's the crystal containment or the anode cathode, right? That's where we need to be able to do the test, but that it's forming out of it's pure monoatomic.
I believe
crystal.
it's an oxy. To me, I think it's an oxidation.
Well, so off the anode side, I would say yes, but the cathode side's where the hydride and the hydrogen.
I agree. Yeah, I was going to say hydrides.
Right, so it's like I kind of suspect it's more of a hydride, and that you get on the anode side, you get a lot of the O3 or oxide monatomic flakes, but that the crystallization, I suspect, is a hydride.
Okay,
because of the water in the reaction, it could be in a chloride as well.
So hold on, guys, just so I can get through this so you guys understand. The energy itself holds geometry inside of it. And I'll say that because when we build out the spheres themselves, what we're noticing is the inside would be 94 kilohertz. In the next layer to it would be 98 kilohertz. And then the next one gets to 102 kilohertz. So as you can see, the frequency difference in it, you know that you're creating resonance inside of each zone that's going at a particular frequency to each one. What we're getting is structure out of that. And when you have that going on in any kind of RAV situation, on anything that's on the cathode, it starts to build out in geometry structure. So that's why they look like, snowflakes or something like that. Or if you build it on the glass, it'll look like a bunch of geometry that's put out there. It's showing the geometry of nature and how nature reassembles things on the opposite side of the reaction, where it breaks them apart on the anode side. So you're seeing the clear transmutation of what's going on.
Absolutely. I love that explanation.
So what do you think about it?
Oh, do you
Yeah,
have?
Dr. Yu.
Okay, as my okay, sure. Convention they say oxidation. I'm gonna be abandon those kind of conventional chemical explanation. So basically, I believe that's Nathan, right? So
Yes.
he was described called a resonance. When you under resonance frequency, what happens? You break original. That's the energy. You break original stable structure, because at the resonance frequency, as long as the input keep a constant, then resonance may create a huge, just like a huge reaction and dislodge them. So that's what a resonance frequency do. Does not have to have a high voltage. No, as long as hit the resonance frequency, you dislodge it. Now, let's see what happens. This happens exactly the same thing as water. Water forms ice, frozen forms ice. You know what that like? That was crystallized. It is still at the boundary. Water at the boundary. Crystallized. So why at the boundary at the resonance frequency? Because you break them. At that boundary, you can break them, and also they try to combine them. They are small enough. They all form them. What happens when they both are charged particle? They are natural. They either form a stable structure or can grow. Grow means north pole attached to south pole. Grow. So that's where the snowflakes, the water at the boundary condition, and the grow. So crystallize. Crystallize means alignment of a magnetic pole. This happens exactly for what we just saw. Is that a hydrogen form, that one, or something else? But it is still the magnetic particle effect. I would assuming if you use a microscope, so take pictures of it. Could be the same, exactly same pattern as a water forms ice, ice flakes. Should be very, very the same thing, because fundamentally they are magnetic particle, and resonance means break them apart. However, at the critical threshold, they also try to merge together. So what happens? Higher magnetic pole connected to higher north and connected to high south. So that's why you see the growth. So basically, this is the picture. Establishing what is the formation of particles, formation of universe. Yes, that's the one. That's exactly how universe formation grow up. Is basically make magnetic alignment, perfect alignment. So that's why grow bigger. I hope that makes sense to you, Bernie.
Yeah, absolutely.
Okay, so maybe you can explain to people. Use your words. Explain what did I say?
So, it's the natural structure and the resonant structure of resonant frequency structure and self-organization that comes out of crystal forming. And so here I've brought up with my ionic gold water, every time I freeze the water with ionic gold in it, it forms the ice with the exclusion zones and these boundaries of bubbles, and that's the self-organization structure of the resonance of a gold element in water
Gold
as it freezes.
crystal. Oh my goodness, that's exactly how grow. Yeah.
Right,
Wow.
so you can see from the top, that's how they form every time with the ionic gold water. Different ice cubes every time. If it's ionic gold water, it freezes into that structure, right? And
Yes.
then vice versa, to show another example that the self-organization of the resonance structure frequency, anytime I do ionic silver water, you get this geometry self-organization in the crystal formation of this vortex, almost like a lightning, so that no matter what, it's the resonant frequency of that mass of the element of the particle in the crystallization that it self-organizes into these specific geometries depending on how that resonant wave energy charge is. So again, these are all the forms of ionic silver. Every single time you're getting this vortex-like tornado
yes.
formation compared to the gold that is the forms with the concentric field circles.
Okay, I have 2 questions for you. I hope that helps other people to understand. Okay, so the first question is you mentioned about self-organize. How could matter can self-organize? What force is that?
Right, so that would be the wave, how the energy is shaped just in itself, right? So that's how it's self-forming in the charge.
I'm talking about that force.
You know, he wants you to say magnetism, Bernie.
Oh my goodness, that's the word. Who said that?
Yes.
Is that Nathan said that?
You got it.
Dr. Yu, I find,
oh my goodness.
I don't define everything as magnetism, but I say that these things at these other scales, that they have magnetic components to them. So
it's the geometry of how the magnetism forms out, I guess. Right?
Yes, you got it.
Exactly, right. So it's a magnetic component to it. And it's like the one thing that's weird is it's like I think people hear magnetism and they think of traditional magnetism. They don't realize the field geometries and the internal and external differential that exists within a magnetic field geometry, the relationship and how they become inverse on the inside of the field, and how magnetic components are dimensional in their nature, whether they're rotational on a plane, whether they're actually growing up at an axis or pinching off to become spherical. And that, in my opinion, is, I think, a big misunderstanding. I wish you could clear up for people, if you agree.
I just wanted to emphasize, you are absolutely right. So-called self-organized is due to a force, and this force has to be natural force, and self-organized has to be autonomously done. What force autonomously done? Naturally born magnetism. So I just want to make sure once you understand that, so the self-organization by what? Every particle has a natural born force. I hope, Bernie, that makes sense to you. Okay.
Absolutely, right. And it's the geometry of that fundamental force crystallizing out and forming into the solidity of it.
Okay. My second question. Okay. So you just showed gold versus silver crystal, different structure. Tell me what caused them different structure.
So that's the resonant frequency building off of its fundamental charge of the, right? So you have the nuclear magnetic as the initial force, and then how it folds back in onto itself. And then that's the charge difference between the different elements. And that's what then creates the difference between them.
Too complicated, your answer.
Okay, yes, right? So give a bit better words, shorter words, please.
Anybody can explain. I try to tell you what's the fundamental difference. Yeah. So anybody, so the question is why gold crystal and versus silver crystal They grow like a different configuration. It looks like different things. What's the fundamental?
Well, that's because of their lattice structuring.
Oh my goodness!
And how it affects the magnetic field and how it could arrange itself in any given confinement.
We have smart people here, okay? Bernie, I
Those
know
are the words I was
IQ,
looking for,
but it's
right?
140,
Lattice
okay?
formation.
And we have another gentleman. Exactly. If you think about it, every particle made by the fundamental particle the same is a muon particle, little magnet. The only difference is a lattice structure, is a magnetic structure difference. Different structure, like a DNA sequence. If different sequence will give you different structure too, right? And so then different structure determine how they grow will be different configuration. My goodness. I have no more questions. I believe you guys got it all. So wow, very impressive. Bernie, I hope that.
I'll simplify everything you guys are saying right now. I'm just waiting.
You summarize it.
Phil's awake. Let's hear it, Phil.
Oh, Phil! Wow.
All right, let's do this. I'll share my screen first. One sec, my computer's a little bit slow when I share my screen. All right, it just woke up. All right. Remember when I showed quickly that paper? I'm basically saying that I agree with what Joe is saying, and what Dr. Yu is saying, and what Bernie is saying, and Nathan. Because in all type of energies, and I calculated it here, all type of energies, you have the magnetic energy, you have the electric energy, you have the gravito-magnetic energy, and the gravito-electric energy, and then you have light, which is kind of combination. But what they all have in common? It's all energy. You have the energy component. It's all in common. So magnetic field and electric field have energy in common. They're distributed differently, but they have a energy component. And what if you simplify a magnetic field and an electric field, then you're gonna have a gravito-electric component in it. All you have to do is either multiply by C, divide by C, or
Sorry, Phil. Do you mind just zoom in a little bit, Phil, on the just so we can see the paper equation? Thank you.
Yeah, and you have the kilograms per coulomb, which is the square root of the Coulomb constant divided by Newton's gravitational constant. That's going to give you the amount of kilogram per coulomb. So with these, and you have here the speed of light again. And with these two numbers, you can convert the amount of energy in a magnetic field, in an electric field, gravito-magnetic field, and gravito-electric field. And they all have the same component. It's energy, but I mean, what is the measurement unit? It's meters per second square, which is an acceleration or a force. If you want, you multiply by mass, it's going to be the force. So magnetic field has a gravito-electric component in it, and I already proved it here in my experiment. I'll show you. I'll play it again right here. So you have a magnet. I repeated that experiment a lot of times, and I increased the spacer as well, so that the magnet does not interfere with the scale, the scale measurement. So right now we're measuring 64.959 grams. Okay, with you have an X here. The X is the polarity. Now I'll reverse the polarity and we'll measure the weight again.
Oh my goodness! Exactly.
So the magnet has around 40 milligram difference if you flip the polarity. And I repeated that experiment a lot of times, not just one time. And why? Why is the weight different? That's because the magnetic field is a force, is an acceleration, has an acceleration vector in it, and that plays a role in the effect, the net force, the weight of the object actually.
Did you? Okay. So let me ask you. So by flipping exactly opposite, so you get a slightly different weight. Am I right?
Yeah, and I have the exact maths to
Right.
I
Then you
have
exactly
the
now.
mathematics.
Now the question is, where did the mass go? Right. I have a theory.
Yeah, it's not the mass, it's the weight. The weight changes.
Oh, okay.
You know,
Yeah.
the mass is the same, but the weight changes because the magnet has an acceleration vector in it. You know, so if you flip the polarity, then the acceleration is gonna go upwards, and if you flip it the other side, the acceleration vector is gonna go downwards.
Yes. You said it right. You know, I just want to make a comment. You are smarter than Albert Einstein. Albert Einstein would have interpreted, oh, mass loss turned to energy. That's exactly the wrong answer. And you just said, we do not have a mass loss. We just lost weight, right?
Exactly.
Where did they? Why? So now my question is, why you lost the weight? Where did that weight go?
Yeah, it's a magnetic field has a gravitoelectric field component in it. And the gravitoelectric field, what is it? Is acceleration, meters per second squared. And actually, it has an acceleration vector that has nothing to do with the magnetic field. So there's that's why if you flip the polarity, you're gonna flip the acceleration vector. So it's either gonna add up to the weight or subtract.
Phil,
You know?
I have answer to this one, but you know, your explanation is too complicated to me, or I did not understand fully. So, Bernie, can you translate what Phil tried to say? Where did the weight loss? Where did the weight go?
I also didn't fully get that, so I would like to hear yours.
Well, can I share my idea first? I don't want it to be spoiled.
So it's the charge, the neutralization of the charge, I believe, of the fundamental force.
Very close, very close.
I think that there's a differential in the energy exchange based on the polarity biased to one side over the other relative to the measuring device itself. So when you flip the polarity, there's a slight change of those differentials, which then quantifies as a measurable result. That's what I think.
I
want the lady try. So can you try? Say they are very close, but yes.
Yeah, but again, it's imagine I can do a better presentation next time, and I can send it to you if you want a PowerPoint or a video presentation.
Maybe we can have a detailed review. With everybody there.
Can I say it?
Go ahead.
Absolutely, Nathan. Let's hear more, Nathan.
You didn't lose weight. You gained magnetic drag.
Ooh.
You gain magnetic drag in it because you hit one of the fundamental fields of magnetism, because you got to think of it this way. Every time you go through a different form of metal to get magnetism, you're going to end up with a different type of magnetic field. And you haven't aligned them all correctly in order to get all of them. You've only got one. Therefore, you get magnetic drag out of the one that you got, versus all the ones that are in the atmosphere itself.
Like, I didn't get that properly. A magnetic drag from, but that's what I'm saying. Magnetic drag is an acceleration,
Well, in this case, it's a deceleration
Yeah,
because
it's either
because of the way you came at the magnetic field, it's a deceleration.
yeah, it decelerates, but if you flip it the other side, then it accelerates.
Anybody want to try, or you want me to say my answer?
Go for it.
Oh, absolutely. Please.
Okay. The Earth's magnetic field impact. When you
Yeah,
rotate,
it's too weak. I already considered it. It's too weak by it's minus to the minus 10 to the minus 10. It's really weak. The Earth's magnetic field.
that's impact.
Yeah, hold on. I got to say this because it's like a capacitor. You can fill a capacitor with every different form of waveform out there as long as it fills. Earth is a capacitor itself. Therefore, it has to see the energy of every different type in there. You only got one magnetic field line that you're talking about and calculating. That's the problem. It's like a clock. You got every little point on the clock as you go around it. You have to calculate for every single one of them. You only got one. It's a
get
capacitor
exactly.
effect. It's the different waveforms and energy. It's the difference between using, say, copper and iron in one form of magnetism, and then turning around and using aluminum and copper and getting a different form in itself. Both will fill up a capacitor. It's the rate of how fast it fills it up. Therefore, they give different magnetic effects.
Yeah, different material have a different effect. One thing about the weight is Earth's gravity pulling them down, right? So that's weight, Earth's gravity. But if the magnet has a north and south pole, if a magnetic pole, okay, I have to explain. So-called gravity, that's Earth's pole. Gravity is a manifestation of magnetism. So gravity is a magnetic
Not a
effect.
force, it's an effect, right? It's
Exactly.
not
It's an effect.
It's effect.
Okay.
No,
I think you
exactly.
you got it. So if you know gravity is a pull, it's a magnetic effect. So now you turn around slightly, just a slightly different, opposite orientation, right? So you see, hey, I lose some weight. But if you tell Albert Einstein, he said, oh, we lost the mass. A mass converted to energy. That would be the wrong answer. Okay.
Yeah.
You guys,
exactly, but
exactly.
But you're right. The magnetic field, the gravity are the same thing. They're energy differentials. What is energy differential? It's an acceleration vector. So we accelerate towards the Earth. As you can see, I can mess around with the acceleration of the magnet, but there's also. So that leads me to you remember the anti-gravity experiment that I did 2 years ago?
Mm-hmm.
Where the mass, not the mass, but the weight of the apparatus increases. Here you can see, I'll play it again. The weight of the apparatus increases when the vortex of gallium starts moving.
Yes, I bet. Phil, were you the one show me drop a magnet?
Yes, sir.
We're far faster than that. Okay, you got the greatest. You got the best experimental evidence for me. Yeah, I appreciate it. That's a good.
I just wanted to add that if you reverse the direction of the vortex, you're still gonna get a weight gain of the apparatus. The amplitude is gonna be lesser, but you're still gonna get a weight gain. So I didn't understand that for some time, for 2 years. I didn't know why. I thought it would be reversed. I thought you would get a weight loss, but you still get a weight gain. But what I really want is a weight loss. So I figured, what should I do? Then since magnetism and gravity and all that, they're all the energy differentials, then I figured, well, the property of the gallium is diamagnetic. So if I convert the gallium into a ferromagnetic material, which is the opposite, diamagnetism has a negative susceptibility, and a ferromagnetic material has a positive susceptibility by a large factor. Then not only you reverse the effect, but by a great amplitude. So if I would add iron powder in the gallium, the liquid metal gallium, then I should get a weight loss by a much larger factor.
So,
But
Phil, I'm just going to add in that that's directly tying back to what Nathan was saying, in that by adding in the iron, you're now increasing another magnetic line into it, and that you're increasing the level of closer to the Earth's actual magnetic field of equalizing it, sort of thing, thus getting that effect, if I understand it correctly.
Yeah, I'll need to talk to Nathan to clarify that. I didn't get everything he said, but I'll need to review what he said. But yeah, so that's what that was my conclusion. The magnetic susceptibility is just a reaction to the energy differential, and yeah, it's very simple. And the permeability that's what it is. Is the susceptibility of a material is just a way that it reacts to an energy differential. So
So we have
it's very
good
simple.
question. We got a good question for your next set of experiments. In that, now you're going to have to compare and try it going through water to see the drop, right? Effects, if it increases or decreases more or less from between air and
Yeah,
well,
yeah, but I would still need to add iron powder in the water.
well, do both, right? That's experimenting. You got to run the experiments of each as controls to then compare.
Yeah, exactly. But unfortunately, my equipment is held hostage by the lab that I still need to refund. That did my experiment 2 years ago. I still need to refund, and then once I pay my bills, I'll be able to get back my equipment. So right now I don't have the equipment. That's the problem.
Fair.
Yeah, it would be cheaper to buy new equipment than refunding the lab when I think about it. But no, I'm not gonna go that bad. But yeah, that's what I want to say. But Dr. Yu, do you understand the concept?
I was sidetracked a little bit. So, can you briefly describe what kind of concept? Sorry, I'm sorry.
Yeah. So the magnetic field, the electric field, the mainstream electric field, the gravito-magnetic field, and the gravito-electric field. It's all the same thing because they all have a gravito-electric component in it, which is acceleration or force.
I agree with that one. Exactly.
Okay.
And I want to emphasize one thing. Okay, I hope you guys feels like not strange. In my discovery, I find out the entire universe is only one fundamental force. That's magnetism.
Yeah.
There is nothing called electrical. So whatever.
So there's. I just want to interject that the fundamental force, and then electric builds off of it as an effect, and then gravitation builds off of that as an effect, and it
exactly.
So it's like it keeps folding up in off of the fundamental force that is the magnetic.
Yes, you're right. So electrical force is emerging for what?
Magnetism.
Vibrating or oscillating magnets. oscillating
at
magnetic field.
and at a perpendicular vector as well, right?
Oh,
That's
yeah. You know
the
why
part.
it's called perpendicular? Just like a displacement versus the velocity, or velocity versus acceleration. That means called the change of velocity becomes acceleration. They are exactly 90 degrees to each other, right?
Yeah.
Change of distance versus velocity. So that's exactly 90 degrees together. Yeah, if you use a vector, say if this is the velocity, the change of velocity, so that means that they have another vector come this way. So the difference is 90 degrees. That difference versus the time is acceleration. So
exactly. So then from gravitation building off of that, it's another degree of 90-degree vector. So it's that then you're going into like, how do you fill in with that extra dimension, right?
Bernie, could I add something here? Eric Dollard, I've been following this electrical engineer for years, and he says there's two components that make what we call electricity. First component, magnetism. Second component, dielectric.
Well, how can electric be part of the electric definition? So I would say that it's magnetism and then motion sort of thing.
Well, you got the dielectric, all right, and you got magnetism.
Can you explain
the reaction of
Mike? Can you define what is called a dielectric?
Dielectric. Anything that is like nothing that is magnetism, ferromagnetic. So say like in my battery cells, I'll have a dielectric medium to separation, create that differential between charge. So, but the charge initially, the charge is done by the magnetism. That's where it all starts, from the magnetism.
Right.
So that magnetic, and then you have your dielectric, and then you have, say, your cathode. When you have that together, that creates the electrical charge exchange, what we call electricity.
Mike, that's conventional. I would suggest you maybe adopt what Bernie just tried to say. It's all fundamental magnetism, and the so-called electrical field or electrical is all called oscillating, the moving magnet.
Exactly, right? So you have the magnetism, and then you have at 90 degrees the motion vector that then creates that electric. So your dipole or your dielectric, that's the medium that it's going through essentially, and one of the charge difference depending on the element and the resonance force or charge of that lattice structure of that matter, essentially.
Okay, here's one for you, Doctor. The Faraday disc.
Yes.
Michael Faraday's Faraday disc. So he has a spinning copper wheel, and he has a magnet in between the copper, okay, creating the eddy currents on the wheel.
Exactly.
Creates electrical currents.
Right.
So it goes back to magnetism to create that force. And when you have a moving dielectric field to create an eddy current, that's when you get a current flow in the vector.
Okay. Mike, tell me what is called the current flow. Can you define what is the current flow?
Current flow? Well, it's the charge itself moving.
Well,
how could the charge moving?
Through the magnetic
field.
It's
the cycle through the mass or through the
frequency.
Lattice. Yeah, the frequency of
no. The motion he talks about is the frequency. That's what Doctor keeps saying. Listen.
Right.
Everything is driven by frequency. Okay.
Right.
Then you get a voltage and you get an amperage on it. So you're driven by frequency. You're driven by the motion. It takes a magnetic field and builds a electrical field on top of it, is what he's saying. And in that, you can drive any system that you want. It takes those three components in order to do everything. The movement of the magnet creates the electrical field, is what he's saying.
Right.
But the opposite is almost true. And here's the part that gets me, is magnetism and electricity are co-linked. They cannot be unlinked. And we know that because you could take a dielectric or an electric and you can spin it and create a magnetic field. So it works in the opposite direction. So they're
Right.
interlinked, and they're the reason they're interlinked is because of frequency. So those three things have to be in conjunction at all times for energy and magnetism to exist.
Well, yeah. So, well, it's said you're right, Nathan. But it's the magnetism is the base fundamental force, while at rest, right? That's the carrier force of it. And then the parallel why it's perpendicular is that vector of motion. It's one cycle that's then creating the electric charge. So, like you said, the dielectric, when you spin it, that's a cycle inversely that's then giving you back into the magnetism inversely from it. My understanding of that. So it's like a cycle of a full cycle. So like I think the definition of the charge is it's like coulombs per second, or I think, right? So, and the coulomb being the electron that goes through, and that it's how many of those, and that so DC, right? Your direct current. That's why it's so much. It's cold electricity essentially, and it's more efficient because you're not you don't have the resistance back and forth through it, right? So that it's not dielectric, it's monoelectric. So it's just the one up, as opposed to fighting itself and having to reestablish the magnetic field.
You're just shifting magnetic fluxes at that point.
Yeah,
that's all you're doing.
Sorry,
you're shifting the magnetic flux in order to not create heat. That's because you paid for the magnet already. You already put the energy into the magnet. You already paid for it. The magnet already has the energy locked into it, right, which is a frequency, voltage, and amperage already locked into it. Therefore, all you're doing in any system is moving the magnetic flux between one side and the other.
Yeah, so like on the Faraday disc, the original one, he uses a copper disc, right? So it's not magnetic, right? Copper's not magnetic. No. So you have the magnet in between the disc and it's spinning. Eddy currents are created on the side of the copper wheel. And those eddy currents now move the magnetism. It's spinning it, and it's creating that movement in current. That's where the current's coming from. Like I built a Faraday disc. You get very high current, but very low voltage. That was the main problem with the Faraday disc.
So, Mike, it's interesting you bring this up because that coincides exactly with what I always say about the electromagnetic mode, the manifestation of the electromagnetic mode based on the vectoring, okay, which I propose is directly related to the dimensionality. And what I've been proposing is that static is zero-dimensional potential. And it's not until you have two, where that line is connected, that one dimension of current is then present. And then once you introduce the next two, remember it doubles every time dimensionally, right? So you have the next two, now you have a plane. Now, what's interesting about the plane is that this is an introduction of scalar and a magnetic component. And the reason for that is you have to have one and the other, you see, because you can't have something that goes inward or outward, okay, without having the inverse present as well. Now, what happens when you have something going inward and outward is they form a relationship, which ultimately turns rotational, okay? And that introduces a magnetic component in the second dimensional plane. Now, once that component builds up, it turns parabolic, okay, and it sweeps onto the into the third axis, doubling once again, okay, into a further more complex magnetic component, which would be a vortex, okay. But like any vortex, all right, as it sucks up into the middle and creates a further differential, the polarity has to stabilize, pinching and collapsing into a spherical torus in the fourth dimension. And it directly correlates with exactly kind of what you were just describing there. And it's through that pinch and through the spherical four-dimensional torus that is, in my opinion, the axis point of the exchange of energy, with matter. and that is the magnetism, is this fourth dimensional to three-dimensional exchange that occurs. And as we know, electromagnetic modes only manifest in the presence of matter. Otherwise, they're transient. They don't manifest in any meaningful way while they're transient. It's only in the relationship matter, which is why this exchange is important. I actually propose that that's the mechanism of time, is based on that exchange rate, and therefore, and also directly correlated with gravity as well, because the exchange rate has direct correlation with the mass, and therefore the magnetism, being deterministic of what that exchange rate is locally, which would lead to a variable, and also point in the direction of entropy, as energy is both captured and held in certain states, like how your cell is able to capture and hold quite a lot of energy potential and then be able to be used. Whereas others go into a more diffuse state, that actually leads to the diffusion of time, which gives entropy and error. That's my opinion of it. I was interested in seeing what Dr. Yu had to say, but I thought that tied right in with what you were kind of just explaining there, Mike.
Yeah, actually, I'm going to pull up a picture of my Faraday disk experiment, so I can show Dr. Yu.
Okay.
So basically, I went a different route with my experiment. I took two very powerful neodymium magnets. All right, so in this chamber here, on the left side, I got two 3-inch diameter neodymium magnets, north poles facing out. On the right side, you'll see the prime mover, which is a DC electric motor. And when I spin those two magnets inside at 3,000 RPM, and you'll see the two alligator clips on either side, those are connected to brushes that touch the outer diameter of the magnets. I get at 3,000 RPM, I'll get 25 amps of current. And now with the Faraday disk, you get low power. So I'm only getting about 80 to 100 millivolts, but I'm getting 25 to 30 amps of current.
Wow.
So
you said that the two magnets,
yeah,
are like pole. You force the like pole facing each other. Am I right?
The like poles facing each other, and I push them together.
So you use a screw, force them together.
Right.
That's all. That's all. That's a real. What is it called? A maglev. That's all did that way. Yeah. You have to force like pole, supposed to
together.
Force them together. You generate the maximum.
Currents. Yeah.
Currents. Yeah.
So I was able to get about 30 amps out of this device.
Wow. So you purchased the overseas, the 3-inch diameter?
Yeah, I 3D printed all the black containers you see there. That's all custom designed by myself and 3D printed. I got
3-inch diameter magnets.
Yeah,
purchased.
Yeah, big fishing magnets. They can lift about 700 pounds.
No, he's asking where you got the magnets from, Mike.
Oh,
sorry,
Amazon.
I'm just running out
Amazon.
for a smoke quick.
Amazon.
Oh, okay. Got it.
Yeah,
thank you.
So they're
I tried to purchase. I'm afraid that to them to detrimental.
They're dangerous. They're dangerous.
Very dangerous. But yes. you did good. You forced them together, very safely, secure.
And very important in this construction, you have to use ceramic bearings.
Oh, okay. Did you happen to measure how much magnetic field extended out?
About 24 inches out.
Oh, 24 inches. Oh, okay, yeah. 24 inches. So 12.
It's about 2 feet.
Yeah. So
about 2
feet. 2 feet. Yes. I believe that's what Bush. What is it? Somebody.
Boyd
Bushman, right? Bushman said extended 3 feet. So his magnet is bigger than yours.
Yeah. His was bigger.
Okay.
Yeah. But it created a very huge field around it. That's why I used the ceramic bearings, because if I use steel bearings, they would just lock up.
Oh no, right. You cannot use anything steel, right? Oh
Yeah.
my goodness. And you cannot take it off. Oh my goodness.
That's why the case is plastic, the bearings are ceramic, and that keeps the amount of resistance to a minimum.
Oh my goodness. Yeah, you have all the pieces to do experiment. Too dangerous for me. So I did not. I purchased a neodymium. The biggest is like a 2 inches bar.
Yeah. The ones I use are the ones they call fishing magnets. So you can get them up to 3.5 inch diameter. I've seen some over 4 inches.
Oh my goodness.
Oh, right. Yeah. So they're called fishing magnets because you put them on the end of a fishing line
Yeah.
and then you put them into the water and it pulls up the metal stuff where it's how they like get the bikes or the guns or the whatever that's thrown into the river or the lake or whatnot.
Like
Joe,
ones,
sorry.
these ones have 750 pounds lifting force.
Wow. Pretty big. So as soon as you're done, Mike, before we wrap up, I know Joe's got a paper that and stuff he'd like to discuss and get a little bit from Dr. Yu's opinion.
Well, yeah, I mean, actually, a lot of what was in the paper was what I was saying before when I kind of related it to, how Mike was talking about, the spinning magnets inducing a secondary magnetic field around the copper, which is revectoring it into a current. And what I was kind of explaining is that the way that I see that magnetism modes changes based on vector. And I see that the vector is directly related to dimensionality. So as I said before, static is kind of representative of a zero-dimensional potential. And it's not until it has a relationship with something else where it actually turns then into a current state in a line. And then when you double that up, at that point, it's on a plane, and there's a scalar potential of an inward and outward, okay, that because of the relationship of the inward-outward turns into a rotational plane. Now, that's your introduction in that context of your magnetic component is that rotational plane of the two scalars. And once that relationship builds, they go through different forms of magnetism when it forms a parabolic sweep that occurs. And basically creating a more defined polarity in a vortex and a generalized torus. And if it's strong enough, if the magnetism is strong enough, then it would ultimately pinch off entirely into a sphere and have a 4-dimensional toroidal, component where there's, centralized compression that is both, there and sharing the space and not at the same time, and because the dimensionality is not aligned, we perceive it as sharing the same space when in fact it's not. Being that it's an upper dimensional object, and it also is the key of energy manifestation in relationship to matter as we experience it, I propose that there's a dimensionality energy exchange that occurs between an actual geometric 4-dimensional energy source, okay, and its relationship with the third dimension as it exchanges with matter. And then there's all the modes of electromagnetism that manifest as a result of that interaction. And I was proposing that the exchange rate between the 4-dimensional and third-dimensional 4D energy and 3D matter, okay, was actually the manifestation of time, okay, as a result of that exchange rate, which directly would also correlate with gravity and how it is affected by mass. And that's why not all large objects necessarily have a high gravitational pull if it's not in relationship to anything else, and if the material that it's made of has a low energy potential, because at that point there is matter that's depleted and less likely to be, to induce this type of energy exchange with magnetism. So, basically that's sort of what I was proposing. Yeah, I wanted Bernie to send you the paper and so you could read through it, but we could save that for another time. But that's sort of the generalized idea. I wanted to see what you thought of that. I know it aligned with some of the things that you had said previously.
Going to quickly interject that I love that then what you're saying is that the time itself is the fourth effect out of where it's magnetism, then it's electricity, then gravity, and then time being the fourth vector into it.
Correct. Yeah. Time is time is the byproduct, in my opinion, of this exchange. And it has to do with the offset differential of how much of that four-dimensional object, so to speak, that is the energy, is present in our 3D space at any given time. Because a four-dimensional object, as it passes through a three-dimensional space, it only shows certain portions of itself at a certain rate, but that rate is linear. As far as how much of it is in that amount goes up proportionally, and it could be exponentially greater the closer to the central axis of the four-dimensional geometric shape, so to speak, sphere, let's say, is in the third dimension. So there's an exchange rate that I believe exists that has to do with magnetism, because magnetism in its spherical toroidal form is four-dimensional. So that's sort of where it was coming from.
Fascinating. I like that.
Yeah.
Dr. You any thoughts?
Oh, I think I'm learning so much. So maybe we'll save sometimes next time. If you guys interested, I wanted to make sure I'm gonna to explain the concept of electrical versus magnetic. I'm gonna try to say how can we unify them into one force, one phenomena. So I noticed there's a confusion here about how electricity works, and is that a moving charge, moving particles, or just oscillating? So yeah, if you guys interested.
Number 3. Yes, please.
So maybe some next
Yes.
time. Oh, okay.
No,
Thank you.
Go ahead. Yes. Go ahead, doctor.
Not at this time, but we're
Okay, a follow-up episode on it. Absolutely.
Yeah, maybe next time, if you guys interested, I will talk about how did I discover the first thing I find. Oh my goodness, electricity is not the flow of charge, is not the flow of electron, and then started there and discover whole theory. So I will explain that process to you.
Absolutely, yes, and 100%, because that will require like your full presentation and whatnot that for us to get it 100%. So in our last 20 minutes here, we haven't really heard from Lulu. Let's you have any questions? We'll get some feminine input here.
Well, I was having the same kind of thoughts as Dr. Yu on, electrical and magnetic field, like the combination of both. Yeah. I don't know if you could see that.
Yes, so we can see the spiral. Yeah, sure.
Yeah. Hold on, let's see if I, yeah. All right. So, you've got the electrical.
Yeah.
And then you've got the magnetic.
Right.
And so, you guys were talking, I was thinking, but and the graph would go something like this, like from the south to the south, and to the south, and then from the north to the north, and the north, and then
yes,
that's the magnetic field. But then you've got the electrical field. If it goes this way, it would be
90 degrees plane. Yeah.
And then but if you want to imagine it in a vector way, my pen is not working anymore.
So what you're saying, Lulu, and sucks, shout outs to Nathan. He had to go to join another stream, but that when regards to the perpendicular 90-degree, that you're hitting on a key part, Lulu, and in your diagram there, that it's having the secondary coil at the perpendicular intersection of your first coil, that you then get the ultimate unity of the Yuan force.
There. Oh my god. But yeah. Yes.
Yeah. That's one part of my theory, try to correct the mistake made by James Clerk Maxwell's equation. Yeah.
So, Doctor, would it be fair to say the second you put electrical charge on a wire, a copper wire, automatically a magnetic field is created around the wire?
That's exactly, yeah, that's right. Yeah.
And that wire is static or it's in motion?
Oh, you know, whenever you have an electrical field, that means the particle always in motion, but motion is not the flow, not the translate, not the transport particle. The motion is oscillating, like this lady drawed circular
It's like a vortex.
Yeah, the vortex time.
Yeah.
You know, but no particle moving away from any point. They just say, while oscillating around their static
like a standing wave sort of thing, like this.
Yes, that's right. Yeah.
So
nothing moves this way. They are oscillating, the changing polarity oscillating. You know how electricity is generated, right? So that means coil rotating in magnetic field, right? Or magnets rotating and a coil in the middle. So what happens? Okay, I can show you this one. Sorry about it. I don't want to take too much. So this is a generator. You know, I have a fixed magnetic field and have a coil inside it. If I rotate it, let me see how to AC. If I rotate it, you may not see. You will see the light come out, right? Yeah. So how does the light come? When coil rotating in magnetic field, so the particles, that atom in the coil changing, atom in the coil, atom is a magnetic particle. So changing phase, right? So that's why you have circular motion. So this is changing. All the coils inside of magnetic field, they're changing because relatively to external magnetic field. So that's the orientation change. Orientation change create a oscillation. The particles are always oscillating, and this oscillation is a wave motion. Every particles are connected by elasticity, which is a magnetic attraction force. They cannot move around, but they can oscillate. But when you're oscillating the whole, that's a wave propagation. That's where all magnetic force create relative motion inside the magnetic field, also changing the magnetic alignment, create oscillation.
So that creates the current.
That's create the current. Yes.
Yes. Oh, I love that, Dr. Yu, and that. So a big part of that too is the difference between the AC alternating and the DC and the single, right? And that you're destroying when you're creating the electric charge in the AC, you're having to destroy and then rebuild that full field charge twice per rotation because of it, as opposed to the DC where you're never destroying it, you're just tapping it, so it's exponentially more efficient.
Simpler words, AC oscillating, changing polarity 120 times per second based on 60 hertz electricity in US. DC, no polarity change, is oscillating in the less than 180 degrees. So that's a polarity always fixed. Why we need that one? Because if you use AC to drive what is it called, water pump, pump water from the swimming pool, like our. Yeah. If you use AC directly, what happens? Pump water out and in, right? The water never goes anyway. You have to make sure the motor always turn it one way. So that's why You have AC coming in, you have to convert it to DC. DC means no polarity change, always within 180 degrees. So that's why you can drive that. You can have a consistent water flow.
Exactly, and that so a big thing with wording and spelling, right? It's that when you're using DC into AC, it's called an inverter. It's inversion, and then when
That's
you're putting
correct. You're using
AC
a
into
full wave
DC,
bridge.
it's called rectifying it. You are
Yeah.
rectifying
Full wave.
that again, right? So it's
A full
against
wave
the
bridge
natural
rectifier.
flow.
Yeah.
Okay,
Yeah.
I think we should save something to next time. Okay.
Absolutely, absolutely.
Can I add something before we wrap up?
Sure.
I just forgot to talk about something. 1 second. All right. Can you pop up my screen? All right.
Yeah.
So remember Dr. Sky Darmos that been to the show a while ago?
Uh-huh.
He has an experiment, a free fall experiment similar to mine, but using different materials, and he noticed a different gravitational acceleration for each materials.
Exactly. Yeah, that's right.
Yeah, and he has his paper is right here with all the detailed results. So he has. So he measures. He measures around a difference in 0.01 milliseconds. 0.1 milliseconds, sorry. Between the lead and the steel ball, there's a 0.1 millisecond difference. The time it takes for I think it's 1.8 meters height. So there's a 0.1 milliseconds. So I did try to to predict his finding using my theory, and I get actually 0.002 milliseconds. So I'm very close. I'm in that Goldilocks zone of his measurement. I still need to work on it. Maybe I forgot something, but I'm using finite theory and the permittivity of the material. Then that's gonna change the acceleration of the that's gonna change the net acceleration, because the material has its own acceleration vector again, and
Just to put the wording of your acceleration, it's the magnetic polarization, like the magnetic. Each element, each material has its own magnetic charge or strength to it, and that's what's not incorporated when you're converting or using electricity or like a quote unquote electron. And that's a big misconception with what the actual particle is and particle accelerators and creating electric particle charge in it, if that makes sense.
Yeah, exactly. Well, in this case, the balls are not magnetic, but they have a different permeability, and that's the different relative permeability, and that's the factor I'm using here, and that differs, and I get a difference between the two the time it takes to fall 0.86 meters actually, and these are the that's the mass. The first mass is 4 4 grams. Second mass is 4.7 grams. The radius of the ball is 5 millimeters. And these are the permeabilities that differs, and I get the different acceleration. I still need to work on it because I'm off by a factor of 100, but I mean, so far so good. It's not too bad. I'm very close to what Dr. Darmos is finding. So, yeah, that's something to look up for next time. Maybe I'll have better results. And if I can get my apparatus back, then I'll finalize the MHD vortex experiment as well.
Amazing.
Before we go off, I just want to show you guys briefly my new solid state electrolyte.
Sorry, Mike. I just very quickly before we let you get that, I just wanted to bring up a picture of, again, this is mine in the electrolysis, the same snowflake crystals forming on a gold cathode, but relating it to the beginning. Sorry, so I'll stop.
Cool.
While you share that, I want to say good night. It was nice talking to you, Dr. Yu, and thank you all for having me. I'll catch you guys next time.
Appreciate
Awesome.
you.
Good night.
Good night.
Take it easy.
So this is the solid state electrolyte I've worked on this last week. So I got all the components.
Uh-huh.
And it's a polymer matrix. It just peels right off. It's like almost like a rubber type substance, but it's solid state.
Okay.
So it doesn't break down. It doesn't leak, anything like that. I got about 5 different elements inside this that I've fabricated. It's got to be heated, stirred for over 2 hours. Then it's got to be set in an oven at 80 degrees for several hours. And then you get this.
So you can make a solid state battery.
That's what this is. Yep. That's what this
Wow. That's the huge research. That's huge money behind this kind of research.
is.
Great. Well, Mike, do you want to show quickly your developed solid state ones that you have? And yeah there we go.
Oh, no
So
kidding.
I got 2 of them here, and then I'll just kind of show you the battery strength.
Okay, so LED lights. Yeah.
Yeah.
So that's 3 volts, right?
Yeah, it's over 3 volts. These 2 cells together will
Oh,
put
yeah.
out,
1.5 each, right? So connected.
well, actually, each one of these, each set of these is 2 volts each.
Oh, 2 volts, so 4 volts total. Okay, so it's brighter than
And my current is about 260 milliamps.
Wow. Okay.
Yeah.
And what kind of plates you on top of? What kind of plates on both sides?
Magnesium.
Oh, magnesium. Okay. Wow.
That's what I'm using. And this carbon graphite.
Yes.
I know a friend of mine knows the guy who's a major distributor of the carbon graphite they used to cool nuclear reactors with. So this is the graphite that they use. It's very expensive.
Oh, okay. Wow.
So it lasts forever, is that it?
Yeah, well, this cell here is designed to last for 20 years. And the best part
wow.
about it is,
Duracell and Energizer. Don't kill Mike. If Mike something happens to Mike, we know who did it, because right?
Oh, my goodness. You made it this work.
so the big problem with magnesium is the oxidation issue.
That's right.
So that's
The,
why
the galvanic decay, right?
That's the limiter of 20 years, right? Otherwise, if the material does not oxidize, it does not decay, you can rest forever.
So the electrolyte is designed not to destroy this.
Oh, wow. My goodness. Do you happen to know called Mike Kent?
Mike?
Mike Kent? There's one gentleman, he made a battery just like that one. He used, he made, we actually, I have 2 of them, but borrowed by somebody. Yeah, it can 1.5 volts for each plate.
Oh, I know who you're talking about. Michael Kantz.
Oh, Michael Kent. Yes, you're right.
Yes,
I
he
said it right.
died. He passed away.
He passed away. Yeah, we tried
Yeah,
to
2022.
purchase. We tried to purchase his garage's leftover.
So
And
my research is based off of what he was working on.
did you get any leftover from him or?
I didn't get leftovers, but I had a little bit of insight on what he was using inside.
Wow. Okay, I'm glad that the knowledge is not being,
So my work is based off of what he was doing, and this
Wow.
is it.
I believe your work could be easily higher, have higher density, longer.
Way higher.
Yeah, than that one. So you are. This is Michael Kent number
Michael
2,
Kantz,
2.0. Yeah, 2.0.
So
Michael Kantz
so-
2.0, right?
Yeah. So these are basically designed. You don't charge them; they recharge themselves. So
Okay.
Right. So
Yeah,
since
you know how they can recharge yourself.
Yeah. Yeah.
That's where I find out that that's very interesting. So based on the so-called charging themselves is use infrared. It is sensitive infrared, so that means you can charge it even in the night. I purchased the 2 of them, 2 sets.
Right.
Each set is 2 layers, right? Yeah.
Yep.
1 layer and substrate. Yeah. So I can make a LED run in my house run for 1 year.
Yeah.
From summer to winter and I stored it even in my work, stored it in metal cabin, completed the metal cabin, still works.
Yeah. So this kind of qualifies as a quasi cell.
Oh, quasi cell. Wow.
Yeah.
Wow.
And that's kind of the holy grail right now for solid state electrolytes.
Maybe one of them is broken. So now I cannot make it. It's not broken, delaminated. So I may not be able to make a LED light work. Maybe I can purchase it from you. So I can demonstrate. This is I called them 24/7 solar panel.
Yeah.
Why is it 24/7? It's not only sensitive to visible
UV, right? It's the infrared. Yeah.
So I find if I put my hands, just warm up the cell with my hands, the voltage goes up. So it's got a thermoelectric.
They're all the same, right? Yes.
Yeah.
Oh my goodness. I'm so happy you made that one work.
It's working well.
My partner tried to make it work and asked me, and I said so he purchased he purchased and keep it in my house for 1 year, and I gave it to him, and then delaminated.
Yeah, but the thing is,
electrolytes is not stable. Now yours are probably much better.
Yeah, I had currents as high as 1 amp. If I go, really heavy on certain elements, I was able to get 1 amp of current. So, like these ones here, they're about 3.5 watts. So, yeah, it's a start, right? But this electrolyte,
that's a huge business opportunity for you.
Yeah.
Wow.
Yeah, I had to get the proper polymer, and the only place that carries it, the type of material I needed is in China. So it took me about a month to get the material in. So it showed up this week. So I've been working on this stuff. So, so I'm gonna.
So it'll be even more developed for next week, and you'll have an extra one for Dr. Yu's partner to sell to. On that note, we gotta end this right to now, just so it's under the 2-hour mark. So the AI will chop it up into a bunch of clips. This was